Hey Geometry, so today we're going to talk about 10.5, applying other angle relationships in circles. First I'm going to show you the different ways that lines will intersect with a circle, inside a circle or outside of a circle. So the first one we're going to talk about is when two lines intersect, they intersect on the circle. Okay, so this would be on a circle. And on the circle is what we talked about in section 10.4, and those were known as inscribed angles. Inscribed is on the circle. A way I like to have people try to remember that is that inscribing is kind of like engraving on something, so it's inscribed onto the circle. The second point of intersection would be inside the circle. When two lines intersect, they are inside the circle. And the third and final way is when two lines intersect, they intersect outside the circle. And today we're going to learn how to find the angle measures and arc measures of inside and outside intersection. So the first one we're going to talk about is angles inside the circle. And angles inside the circle is when two chords intersect inside the circle. Now, when we're looking for the measure of the angles inside the circle, the measure of the angles inside is 1/2 times the sum of the measure of the intercepted arc and its vertical arc. Okay, so what that means, if you look here at the picture at angle 1, angle 1's arc is arc DC because angle 1 intercepts the circle right here at DC. Now, that's the one arc that you take into consideration. And the second one you look at is its vertical arc. So the vertical angle to angle 1 is this one here I'm highlighting in blue. So the vertical arc from arc DC would be arc AB. So if I were to write how was I going to find the measure of angle 1, I would be taking 1/2 times arc DC plus arc AB. And that's how you find the measure of an angle inside the circle that is not at the center. So if we go to the first example here, the measure of angle 1. Okay, so here is angle 1. I'm going to go ahead and just highlight this angle so I can find the arc that it intersects and its vertical. So I know that angle 1 is inside the circle, so I'm going to be taking 1/2 times the sum of its arc, so angle 1's arc is 220, and I'm going to be adding the vertical arc, and that is the arc that is back to back with this. So I just find that vertical angle to angle 1 and use the arc that that vertical angle intercepts. So that one would be 40. Okay, so I'm going to be doing 220 plus 40 and then multiplying by 1/2. And multiplying by 1/2 is also the same thing as dividing by 2. So I am going to be taking 1/2 of 220 plus 40, which is 260, and 1/2 of 260 is 130 degrees. So the measure of angle 1 is 130 degrees. Number 2, I'm going to circle. This is going to be your checkpoint that I'm going to check tomorrow. I do want to help start setting this one up because it's a two-piece problem. Notice that the first question says find the measure of angle BEC. So all I'm going to do is I'm going to highlight this is what you're trying to find first, where I'm putting this green dot. You need that angle first, then you need to find angle 1. So I'm going to leave the rest of that for you to do in your checkpoint. Now we're going to look at angles outside of the circle, and angles outside of the circle when a tangent and a secant, two tangents or two secants intersect outside of the circle. To find the measure of the angle outside of the circle, you take 1/2 times the difference, I'm going to abbreviate there, of the two intercepted the two eaten arcs. Okay, so if you look over here at the picture, the angle is outside the circle right here. But this angle, when it intercepts the circle, it hits the circle in 4 different points. It's 2 different arcs created. It creates this big arc, and then it also intercepts this smaller arc. So how I like to think of this is that if I were to find the measure of angle 3, which is that little angle up there, I would take the measure of arc. Sorry, let me erase this so I can see it. The measure of arc BC minus the measure of arc AB. Okay? This is the big arc, and this is the small arc. So a lot of times I'll refer to this as take the measure of the big arc minus the small arc, and that's going to give you the measure of the angle outside of the circle. And of course, don't forget to multiply it by a half. So if we look at these two examples together here, this number 1 says find the measure of x. I notice that x is right here. It is outside the circle. So I'm going to highlight my angle here, and I find 2 arcs. I found my big, and I found my small. So I'm going to take 1/2 times my big arc, which is 80, minus my small arc, which is 20, and that is going to give me the measure of angle x. So 80 minus 20 is going to give me 60, and half of 60 is 30. So the angle x is 30 degrees. Okay, and then number 2, this is also an angle that is outside of the circle. I'm going to highlight this angle. But notice that our x is in a different position. That's okay. We're going to use that equation. Half times big arc minus small arc equals angle. So I'm just going to plug in the pieces that I have. So I know I'm taking 1/2 times my big arc, which is 185, minus my small arc, which is x, and that is going to equal my angle. And now I just have an equation to solve. What I suggest you do first is to get rid of that fraction so we don't have to deal with that. So to cancel a fraction, I'm going to multiply by a reciprocal, which the reciprocal of 1/2 is 2. So now I have 185 minus x equals 80 times 2, and 80 times 2 is 160. And now I'm going to start solving for x, so I will subtract 185 from both sides. And I'm going to get a negative x to equal a negative 25. To get x alone, I divide by negative 1, so x is going to be 25. So in this case, I was looking for the other piece of the arc. So when you're using inside and outside angles, use that equation with the big arc and the small arc for the outside, and the arc and its vertical arc for the inside. Use them as an equation and just plug in what you have and solve for the missing piece. So tonight, don't forget to do that checkpoint problem that I kind of started for you, and then we will go through these class notes tomorrow together. See you then.